Here we go. Okay, guys. This is additional practice 3-5, and you will all have this. You need notebook paper and your pencil, and you may also use a calculator as we complete this, okay? So you did notes on this either Thursday if you were first period or Friday if you were second period. And so this is practicing what we've done on notes. This is our additional practice. So we're going to work through this, okay? If you are not with us today and you have this paper, or even if you're not with us, you could pull out notebook paper and do it. You don't have to have this exact piece of paper to be able to do it. That way you're not so behind when you come back. But that's if we're feeling great. I don't know why you're out, if you are. Anyways, so it says in 1 through 8, find the value of each expression when A equals 1/3. That's 1/3. I was just scratchy there. B equals 9. C equals 5 and D equals 10. Okay, so we're just going to start working through this. One thing I want you to remember and understand is that when you see, and we're learning new words, when you see a number, an integer in front of a letter, okay, this letter is referred to as a variable, and that number is referred to as a coefficient. So we have a coefficient and a variable next to each other with no operation symbol. That means you're going to multiply, okay? And you need to have your order of operations notes out because you have to apply that as you complete this problem. So 6a plus 4, all right? 6a plus 4. So I'm going to rewrite my problem, and I won't be doing all of them for you. I'm just helping you get through some as an example. 6a plus 4. Now, I know some of you are saying, I can do all my work right there. Yeah, no, I'm asking you, more like telling you, you will do this on a separate sheet of notebook paper. You can write your answer next to the problem. 6a plus 4. You've written your problem. We know that a equals 1/3. So watch this. 6, and you're going to open parentheses, times 1/3, okay, plus 4. All right? So you can put that in your calculator, okay? Why does it hate me? I'm going to make it brighter. Brighter? Oh, ooh, that's better. Okay, so 6 times, and we're going to make one numerator denominator, third. Remember, push your arrow over, enter. We get 2. On this calculator, because most of you have this at home, if you're at home, or even at school. 6 times, again, open your parentheses, and you're going to do 1 numerator, 3, arrow over, and then close your parentheses. So same idea. There you go. Okay. Same button. So 6 times 1/3 we found out is 2. So rewrite this. 2 plus 4 equals what? 6. Okay? That's it. So you're going to come up here and you can put 6 as your answer. You can box or circle it for number 1. I'm going to do number 8 with you. 8 looks like a doozy. Okay? And again, all your work must be on a separate sheet of notebook paper, and you need to identify your problems. So I'm going to rewrite my problem. 3c plus b squared divided by 27a minus d. That's a lot of variables. We have all 4 variables, and we're going to apply them all. So that's a coefficient 3 with a variable c next to each other means multiply. So 3 times, I'm going to open my parentheses. I'm showing I'm going to be multiplying it. What is c? C is 5. 3 times 5 plus, what is b? B is 9. 9 squared divided by 27, open that parentheses again because we're multiplying A, which is 1/3, minus D, which is 10. Okay? So I'm going to apply my order of operations. So these parentheses do not really count as parentheses or working really as multiplying. So parentheses, exponents. Exponents is next. And I do have an exponent. Now remember, 9 to the power of 2 is the same thing as saying 9 times 9. Okay, so I'm rewriting 5 plus 9 times 9 is 81 divided by 27 multiplied by 1/3 minus 10. So parentheses, exponents, multiplication, division. Remember, we are going to work left to right as if we're reading a book, doing multiplication, division as it hits us. First thing, 3 times 5 is 15. We're not doing addition yet, plus 81. We're not doing that, okay? Divided by 27 times 1/3. Now here's the thing. You're going to want to do 81 divided by 27. But please remember up here, this is stuck together. We're going to do this first. So kind of treat it like parentheses. So, and then minus 10. So I have addition, but I'm going to do this first. Think of it like parentheses. 27 times 1/3 is the same thing as saying 27 divided by 3. Okay? 27 divided by 3 is 9. So 15 plus 81 divided by 9 minus 10. So now I have addition, division, subtraction. Again, I still have multiplication, division, so I have 15 plus 81 divided by 9 is 9 minus 10. All I have left is addition, subtraction, work left to right. 15 plus 9 is 24 minus 10 equals 14. Okay? So up here, number 8, I'm just going to put 14 below. Circle that. All right. So 9 through 11, they are telling you to evaluate each expression where x is 3.1, x is 6.2, and this x is 8.3. Do you see that? Aha, I get it. Okay. This x is going to be 3.1. Number 10, this x is 6.2. I don't like the way they organize this. And then 11, this x is 8.3. Okay? Well, I don't like how they organize that, but just so you know, that's what you're going to do. Okay? Ew, I don't like that either. Okay, so that's what you're going to do. And so I'll do number 11. X equals 8.3. So I'm going to, number 11, x equals 8.3. 2 times 8.3 plus 1.5 times 8.3. Okay, so I'm going to use my calculator for this. 2 times 8.3 is 16.6 plus 1.5 times 8.3, 12.5. Oh, 12.45. We're going to add 16.6. You get 29.05. Okay, so come back here. You have 29.05, and we're just going to cross that one out because we used it. Okay, I hope that makes sense. 12 and 13, they want you to evaluate each expression for the set of values given in the table. So they want you to evaluate this 3 times. So where C equals 1, okay? So 12, we're going to do 12. where C equals 1, okay? And we have 28 minus C to the power of 3 plus 6, which is 28 minus 1 to the power of 3 plus 6. Remember, 1 to any power is, 1, because 1 times 1 is 3. So I get 28 minus 1 plus 6. 28 minus 1 is 27, plus 6 is 33. So you're going to put 33 in that box, okay? And you're going to solve for C equals 2 and then C equals 3. Same thing down here where T equals 0.01. You're going to solve like we did number 12. And the same thing where it equals 1 and equals 2.5. All right? So let's talk about 14 and 15. It has a great table that we're going to reference. Okay. It says, model with math. Tamara has a pet sitting business. The table shows how much she charges. Last week, she sat for 1 dog and for 2 cats. Okay. Letter A says, suppose that Tamara spent 8 hours sitting the dog and 2 days sitting the cat. Write an expression that shows how much she earned. So over here, 1 dog per day is $20, or per hour is $7. 2 dogs, $25 per day, or $9 per hour. 1 or 2 cats, $15 per day, or $6 per hour. Okay, so you need to write an expression. So she spent 8 hours sitting the dog and 2 days sitting the cat. So I want you, and look at your notes and things that we've done. Think about this, okay? Think about what we know. So she spent 8 hours sitting the dog. Do we know how many? No, we don't. But she spent 2 days sitting the cats, right? How much per day? Yeah, 15, okay? Write an expression that shows how much she earned. So you have 2 days of sitting cats. So 15 plus 15 is 30. So $30 plus, and then 8 hours sitting the dogs. So here's the thing. They said 8 hours, not days. So how much per hour? 7 plus 7. And do we know hours? No. And that's it. So $30 because it was 2 days of sitting cats plus $7 per hour for the dog. Okay? Now, that's our expression. But come down here to B, evaluate the expression you wrote to find how much Tamara earned if she sat for 2 hours. So now we know what H equals. H equals 2. So 30 plus 7 times 2 equals 30 plus 7 times 2 is 14 equals $44. It's not bad work, huh? So 15, for any of the pet sitting services listed in the table, how many hours can you purchase before it would be cheaper to pay for 1 day? Okay, so they're asking you if 1 dog per day is $20 or $7 per hour, how many hours would you dog sit before you paid too much and just reverted to $20 per day? Okay, and then 2 dogs, same thing. If it's $25 a day or $9 an hour, how many hours before it's too cheap? And same thing with cats. So think about that and you tell me. Turn it over. Okay. I have the deli sells, number 16, the deli sells ham for $3.95 a pound, turkey for $4.30 a pound, and cheese for $3.10 per pound. Write an expression that shows how much it will cost to buy H pounds of ham, T pounds of turkey, and C pounds of cheese. Okay, so what they're saying, and we had this on our notes and our homework actually, excuse me. So ham is $3 per pound, but we don't know how many pounds. So we're going to say $3.95 is our pound of ham. So we don't know. $3.95 per pound of ham. Plus, we're getting a lot of things. $4.30 for T turkey, plus $3.10 for C cheese. That's it. And now they're telling us, well, now I want to buy 1 pound of ham, 1.5 pounds of turkey, and 2.3 pounds of cheese. So now you have a value for ham, which is 1, so H equals 1. Turkey is 1.5, and C, cheese, is 2.3. So you want to multiply those and then add the 3 together to know how much it cost to buy your ham, turkey, and cheese. Okay. Number 17, model with math. Juan rented a paddleboard for $5.75 per hour plus a $17.50 fee. Write an expression that shows how much it will cost Juan to rent the paddleboard for X hours. Okay, this is a real world example because if you've ever gone to the quarry in Knoxville, it's a really cool place. You should ask your parents if you've not been. And you can rent paddleboards, canoes, and kayaks. And they make you pay like $20 up front and then so much money per hour. Okay. So we know the constant, never changing. This was also in your flip book. We know it's going to be $17.50 period plus $5.75 per hour. And now they're saying, well, now we're going to tell you your hour H equals 3. So solve and figure out how much it's going to cost you to go do that. Okay. So number 18, be precise. The table shows how much a frozen yogurt shop charges for its yogurt. Okay. Write an expression to show how much it costs to buy a small yogurt with no toppings and a large yogurt with X toppings. Then find the total cost for a small yogurt with no toppings, and now my large yogurt's got 3. So I want a small yogurt with no toppings. So that constant is going to be $2.85 because I don't want toppings. So $2.85 plus somebody wants a large yogurt, one of my boys, they want a large yogurt, but he has not decided how much he wants on his yogurt. So we're going to say X toppings. We don't know what X is yet, okay? Because, you know, sometimes he likes to get cherries, and then they all like those silly gummy worms, you know, but they're 35 cents per topping on the large. And then we get to the end, and Gabe says, I want 3 toppings. So now you need to solve for X and add that to $2.85, and you will know how much it costs for that yogurt. Number 19, a school district can send a representative to the state spelling bee for every 50 students in the school district that year. There are 5 schools with A, B, C, D, and E students respectively. Write an algebraic expression to show how many representatives the school district will have in any year. So, this is very good. Very, very good. You know, so, it is big numbers, okay. There's different ways you could do this. You could do, I like this one. Each school can have a representative for every 50 students. So look at it like this. I have 1,587 divided by 50 plus 985 divided by 50 plus, here, see where I'm going, 2,052 divided by 50 plus 824 divided by 50 plus 752 divided by 50. Ms. Collins, what do you mean? So what I mean is that when you do 1,587 divided by 50, so here's the thing. It's going to take rounding, 1587 divided by 50, because you're not going to get a whole number. You get 31.74. Well, you won't chop off 0.26 of a person and say, here's your 0.74. You have to round it down. So how many students could they have from this? 31. Okay, so you're rounding down. Okay, so this would be 31 plus, and then you got to divide the next one and then round it down. So you would be taking away that decimal and just end up with that whole number. That's what you want. Okay. Okay. Everybody got it? Okay. So the table shows the number of students at each school this year. Use your expression to find out the number of students at each. Look at that. So you're just going to, and then we just explained it. Oh my goodness. So I hope you can do it because you are awesome sauce. And then here's some assessment practice, very TCAP-y of them. So we have an expression is shown, 3r minus parentheses, r plus 0.47 close equals 3 and 1300ths. Which value of r makes the equation true?
Have a good one.
So what you could do, that's what you're going to have to do. You're going to have to plug in this value for r each time.
Sorry about your table with no legs.
That's okay. We're just doing a lesson here. That's all right. So you're going to have to figure out, like plug it in. So I'll do one with you. I know you're all like, please do one with me. Mr. Gamble, he came and he apologized about our poor little table with no legs. Life goes on. Equals 3.113. Okay. So I'm going to plug in 0.8 minus, open parentheses, 0.8, oops, no plus 0.47 equals 3.13. Okay, so we're going to be balanced because what you have right now is an equation, and they said equation. And one thing, and I've told you this before, haven't talked about it in a while, but the difference between an equation and expression. An equation is two equivalent expressions, meaning this side here, when solved, should equal this side, because that's what makes an equation, two equal expressions. So I'm not going to worry about this guy right now. I'm just going to solve this side. So I have 3 times 0.8, which is 2.4. 2.4 minus 0.8 plus 0.47. 1.27. 1.27 equals 3.13. So watch it, just stay with me. So now I'm going to do 2.4 minus 1.27, and I get 1.13. Yep. Look at this. Does that equal 3.13? It does not. It does not. So that is not equal, and then that cannot be an option. So you see what I mean? So as you can see, that was very low. And if I was doing TCAP, and I'm looking at all of my choices here, and I started with 8/10. And when I solved it, this was two away from this. So that was kind of a low number to start with. So if I was doing TCAP, I would go to this end to a bigger number and start with that. Okay, instead of working my way up. Now that I know this is not even close. Okay, but you need to figure out by, again, showing your work on a separate sheet of paper. Okay, love you guys so much. Happy working. You were doing great. We're going to get there. We're going to get there. We're going to get there.